Hi, my name is Josh Cabello, and today we'll be building a weather station using a Raspberry Pi and a Raspberry Pi Sense Hat. I'll also be walking you through some code, and together we'll be able to use the Sense Hat in order to let it display the sensor readings through its LED matrix, as well as store it in a log file, and even upload our results to a Google spreadsheet. Here is a diagram of how the project will be formed. You can even see the individual functions each part will play, gathering data and sending it out. Most of the functionality will be handled by the Sense Hat, but the Raspberry Pi serves as the brains of this operation, handling the data once the sensors retrieve it. In order to build our project, we're going to need a couple things here. So I have with me the Raspberry Pi, of course, but you also need this right here. This is a Raspberry Pi Sense Hat. I'll show you how to install that momentarily. You also need the power supply, so I have a USB adapter to DC, as well as a micro USB cable. So this one here has a little switch on it, which will help us turn the Raspberry Pi on and off. I also have a USB keyboard right here. And for my display output, I'm going to use a TV. You can use a monitor or another device if you have an adapter for it, but I just chose what was convenient for me. Installing the Raspberry Pi Sense Hat is relatively simple. As you can see here, I have a little bridge that goes right on top of the Raspberry Pi's GPIO pins. So just line it up and give it a firm little push. It doesn't have to go all the way in, it just needs to rest on top. Now if we take our Sense Hat, you see here is also another set, just like that. And on the bottom, you see tiny holes. So these go right there. They just line up and you push it down. That's all you need to do. Once you have the Raspberry Pi booted up and ready to go, you're going to want to open up the terminal and enter these commands found on my website. It's a lot to do and it will take some time, but it'll ensure that all things we require for the project are available to us when we need them. Here I'll show you a brief look at the code. Right now I have it set up so that it can use the Sense Hat to read the temperature, humidity, as well as the barometric pressure, and then display the results out to the Sense Hat's LED matrix. More information on this code can be found on my website. Now, let's go to the Raspberry Pi and see how it looks. Okay, so at this point, our program should be able to grab the sensor data and output it to the LED matrix on the Sense Hat. Let me run the program and see here. There we go. As you can see, the Sense Hat now displays the temperature in Celsius, the humidity, as well as the barometric pressure. We're above sea level right now, so a little over 1,000 millibars is just right for us. While the LED matrix is nice and all, we need a more permanent solution in order to store our information. Writing to a log file will accomplish this. As you can see here, I have appended my previous code with a little more. What this line does is it'll allow us to store the information to a log file, a plain text file, in the same directory as our program. Here we have it formatted in a specific way. This will allow us to more easily read the information. Now, let's run this code and see what the log file turns up. Once you run the program again, you'll see it create a new text file. I've opened up mine on screen here to show you how I formatted it. As you can see, I've run the program quite a few times over the past month, and my program updates it every time I take a new reading, including this one down here. This is the one we just took. Now, before we can continue coding, we're going to need to activate a couple things in our Google account. You'll find a link in my website, but in general, we're going to create a new Google project using their API system. Now, create a new project, and then we're going to activate a couple APIs. So if you go to the API library, you're going to need to activate two things: the Google Drive API here, as well as the Google Sheets API. We're going to need both of those services. As you can see, I've already enabled these APIs, as they are marked by a green check mark. Once you've activated the APIs, go to the credentials page and create a new service account. Fill out the form, and this will be the email used by your Raspberry Pi in order to update the spreadsheet. As you can see, I've already have one listed down here. When you create a service account, you should be given the opportunity to download a JSON file. You'll want to save this because it contains vital information that your Raspberry Pi is going to need later. I recommend saving this to a USB device and then transferring it to the Raspberry Pi. Save it somewhere simple, like the desktop. Now that that's out of the way, let's create a new Google spreadsheet. As you can see, I have one set up right now, but there's too many rows. We're going to format this so that the program can function properly. What we'll do is we're going to Control A, Control left click number 1, and then right click, delete rows 2 through 1000. This will give us a spreadsheet with only one row in it. Do not worry about adding any new rows to this spreadsheet. The program will automatically update the spreadsheet with a new row after it enters the sensor data. Now, let's head back to Python to add the new code. Once you're finished setting up the Google project as well as the Google spreadsheet, we can now enter the new code into our program. You'll want to be especially careful of this line here. This will be our service account credentials from the JSON file we received from the Google account. If you do not have this file, and you do not specify the correct path to that JSON file, this portion of the project will not work. Now, once you finish with that, we can now go back to the Raspberry Pi, run the code, and see if it updates our Google Sheet. Okay, so as you can see on the screen here, I have the Google spreadsheet open. As you can see, there's a lot of sensor data to go around. And this is the last sensor data we just took. But if I run the program again, it should be able to update the spreadsheet once more. Now, because this uses your internet connection, it may take a while for it to update. And this is just going to depend on how your Pi is connected to your internet connection as well as your internet speed. But as you can see right there, we have the brand new sensor data taken just now, line 30. As you can see, it is beautifully formatted and added automatically. Don't have to type it in. Now, if I were to right click on one of these cells down here and look at edit history, you'll see it was edited not by me, but by someone called Weather Sheets. And the time they edited it actually matches the timestamp of our date and time over here. This person, Weather Sheets, is actually what I call the Raspberry Pi when it writes to my Google Sheets. As I have shown, the Raspberry Pi equipped with a sensor can be a powerful tool in any IoT system. In fact, many services are built around adding additional functionality to projects such as this. Initial State is a cloud service that offers many utilities specific to IoT devices like the Pi. I was unable to incorporate them into the project, but Google's API service has proven to be a suitable alternative for those looking to enhance their IoT experience. Environmental sensors such as this are used heavily within industrial spaces. Businesses often employ devices that monitor not only temperature, humidity, and barometric pressure, but also gas levels, water purification, or even light or color. Keeping track of these types of data is important if specific conditions need to be maintained at all times. For example, a data warehouse would desire indoor temperatures stay cool and with little humidity to prevent damage to computer equipment. That concludes my presentation. I hope this project has sparked an interest in putting together your own Internet of Things device. I would like to extend thanks to the many resources I used to create this project in the first place, as well as to all of you for tuning in to this video. Thank you, and goodbye.
Yes, I have a question. Have you considered changing your date format to the general form, year, month, day, and then hours, minutes, seconds? And I say that because if you're going to use Google Sheets, the implication is you can do a lot of data analysis. And if you do the year, month, date, hour, minute, second, if you sort it that way, it's back to its original state. And if you have to sort it other ways, you don't really lose the original format. And that's kind of a neat trick. And I thought I'd ask if you considered it.
I did not consider that. I was just looking for something quick and dirty. I was basically using ASCII Times library in order to put the date there.
Some years ago, I started doing that. I had a project manager who was driving me nuts saying, well, we can't change the way we do date times. Like, come on, guy, get some sense. Do it this way and make life easy for everyone. But he didn't want to do it.
Yeah,
I do it now.
Yeah, I can see the benefit of being able to sort individually by year, day, and month. Yeah, if I do this again, like for another project, I might consider that.
Tell Josh, it is a really, really good presentation. Yeah.
Thanks.
Well, good job.
That is, what is the most important point that you learned from this exercise for your project?
I think the most important point is the importance of knowing how to program, because this project that I did, and I'm sure Ed also had to do it too, and Karima, is that we had to program the Raspberry Pi in order to do these functions. It's not just opening up some application on your desktop.